Hello guys, welcome back to my YouTube channel. So today we are going to solve problem number 2275, largest combination with bitwise and greater than 0. Okay, so let's read the problem statement first. The bitwise and of an array nums is the bitwise and of all the integers in nums array. Okay, so for example, for nums is equal to 153, the bitwise and is equal to 1 and 5 and 3. Okay, so how you are going to write 1 in binary form? You are going to write 1 like this, right? And how you are going to write 5 in binary form? Okay, so this bit value is 1, this bit value is 2, this bit value is 4. Okay, so you are going to write 5 like this, right? And if you do the bitwise and of these two, you will get the output like this. Okay, so let me draw the AND table. Okay, so if two bits are 0, we will get output as 0. If one bit is 0 and one bit is 1, we will get output as 1 as 0. If one bit value is 1, 1 is 0, then we will get 0. And if both are 1, then only we will get one output. Okay, so this is our bitwise AND table. Okay, so A and B, and this is the result, which is nothing but A and B. Okay, so this is my truth table. Okay, so here for 1 and 5 I get this output. Okay, now do the bitwise AND with 3. Okay, so 3 I'm going to write like this in binary form. Okay, and do the bitwise AND of this, so we will get output as 1 here, 0, and here 0. Okay, so in the end, see, this is nothing but 1, so that is why we are getting output as 1. Okay, for num7 single number is there, so bitwise AND is 7 only. Okay, you are given an array of positive integers candidates. Evaluate the bitwise AND of every combination of number of candidates. Okay, each number in candidates may only be used once in each combination. Okay, return the size of largest combination of candidates with a bitwise AND greater than 0. Okay, this is what we need, right? So here if I have numbers like this, okay, let's say 0 0 0 0, and here 1 1 1 1. Okay, what is the output that I'm going to get? I'm going to get the output as 0, right? We have to return the size of the largest combination of candidates with bitwise AND greater than 0. Okay, but the number is not greater than 0. So for my result to be greater than 0, I need a bit where both the values are set. Okay, where both the bits are set at particular position. Okay, so this is 0, this is 2, 4, and 8. Okay, so here see, this is set. Okay, and this is also set here. In that case only I will get my result greater than 0, otherwise I will not get. Okay, so I will just simply check the numbers where my bit is set at a current bit position. Okay, like this. Okay, so if this is the case in two numbers, okay, then definitely I will get the result greater than 1, greater than 0, right? So now let's understand this with example here. Candidates 16 17. Okay, these numbers are given to us, right? I have written all the numbers 16 17 71 62 12 24 and 14 in binary form. Okay, so this is how we represent 16, right? So here what we will see here, so right, this here, let's say this is 1. Okay, I'm writing 1 like this, 0 0 0 1. Okay, and let's say this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. Okay, and my next number, let's say it is 3. Okay, so here I'm going to write 3 like this. Okay, so here what is the output that I'm going to get? I'm going to get the output definitely greater than 0, right? Here this is the output that I'm going to get. Okay, if I do the bitwise AND. Okay, so this is good. Okay, so this is the output that I'm going to get. Okay, so now next time let's suppose a number comes like 4, and I'm going to write 4 like this. Okay, 0 1 0 0. So for this I will get my output as 0. Why? Because at this position there is one bit whose value is 0. At this particular point there are two zeros. Okay, so there are two zeros here, there are three zeros here. Okay, so I need a numbers. Okay, 1 and 3 are forming one combination because there is one position in which the bit is set, one bit is set. Okay, at a particular position. Okay, so here see, here see at bit 0. Okay, this 2 bar 0 or bit value 1. Okay, so here see, these two bits are set. Okay, so two numbers, I can form the combination of these two numbers and I will get my output greater than 0, right? And here I can form combination of 71 62 and 14 as well. And if I form the combination of these two numbers, then again I will get the output greater than 0. Okay, and here total four numbers are like this. Okay, total 4 bits are set, and here also 4 bits are set. Okay, 4 bits are set, here also 4 bits are set. Okay, so these are different combinations that I can make. Okay, 4 4 4. So here what is the combination that this example is taking? 16 17 62 and 24. Okay, 16 17 71, okay, 16, 17 and 62, 24. Okay, 16, 17 and 62 and 24. Okay, so here see, 16 this bit is set, 17 this bit is set, 62 this bit is set, and 24 this bit is set. Okay, so at bit 4 position, okay, at this position you see total all the bits are set for these four numbers. Okay, so they can form one combination, and there are many other combinations as well in this example. Okay, 62, 62. Okay, let me highlight this. 62, 12, 24 and 14 are also forming one combination. See, all these bit values are set here. Okay, so they are also forming one combination. Okay, and there are many other numbers like this. Okay, so 71, if you do the 71 and 62 and 12 and 14, then again you will get the bitwise AND result greater than 0. Okay, so we need, okay, if we are forming the combination of any two numbers, we need at least a position where all the bits are set. Okay, all the bits are set in a particular position. Okay, so this is the requirement here. Okay, so what I'm going to do, so in Java the integer size is 32 bits. Okay, max and min. Okay, so we can represent it 32 bits. Okay, so I'm going to check all the bits one by one. Okay, so this 0 at 0 index. Okay, I will check the bits which are 1. Okay, and if they are 1, I'm just going to increment the count of those bits. Okay, so here 2, so 2, 2. Okay, so then I will check this position. Okay, I will check the number of set bits at this position. Okay, at this particular index, total 3, so 3 is greater than 2, so my latest is 3. Okay, and then I will check at this particular index. Okay, so here I will just give the indexing. Okay, 0 index, let's say 1 index, 2 index, 3 index. At 2 index I will check all the numbers where that particular bit is set. Okay, so I will get 4 numbers, so 4 is greater than 6, so my max will be 4. Okay, so this is what I need to do. Okay, so simple. Now let's write the code. Okay, so here first thing, let me show you this. Okay, let me just maximize it. System dot out dot println integer dot size. Okay, now here let me just return 0 so that we'll see the answer. Return 0. Okay, so now let me run it. So see, the size that I'm getting here is 32. Okay, so max size. Okay, so I will check the 32 bit positions. Okay, like this 0, 1, 2 index, 3 index, 4 index. Okay, this is nothing but 2 power 3, this is nothing but 2 power 4, this is nothing but 2 power 5, this is nothing but 2 power 6. Okay, like this. Okay, so now let's write the code. So here, simple thing that I have explained, I'm going to write the same thing. Okay, here, so first let's calculate the length of my candidates. Int n is equal to candidates. Okay, dot length, and max count is equal to 0. Okay, then run one loop for int I is equal to 0, I is less than 32, I plus plus. Okay, and here int count is equal to 0, and let's iterate over all the numbers one by one. Int num in my candidates. Okay, and inside this I will just check if that particular bit is set or not. Okay, so how I'm checking, if num, and I'm going to do the AND with 1 left shift it with my I. Okay, and if this is greater than equal to 1, okay, then in that case increment the count. Okay, and here I'm just going to update my max count as math dot max of count and max count. Okay, and here in the end I'm just going to return max count. Okay, so this is the best way to find out whether our bit is set or not. Okay, so num and 1 left shift with I. Okay, so let's say I want to check. Okay, let's say a number is like this, 1. Okay, 1. Okay, so this is how I'm going to write 1, right? 1 2 4 in binary form. Now I want to see in this 1 if this bit is set. So what I'm going to do, 1 left shift, I'm going to take another 1 and I'm going to left shift it with 1 position. Okay, I is 0. Okay, initially let's say I is equal to 0. Okay, so this is at 0 index, let's say. Okay, so I'm going to left shift 1 with 0. Okay, so 1 will remain like this only. So if I do the AND of this one, so I will get my output as 1. Okay, so yes, so if the output of this is greater than equal to 1, then that means simply that is set. Okay, so here let's take another number. Okay, let's take 4 or 4. Okay, let's take 4. So here 4 I'm going to write like this, 1 bit value 2 4 8. Okay, I'm going to write 1 like this. Okay, a 4 like this. Okay, now I want to see that if this bit is set. Okay, so this is index 0, index 1, index 2, index 3. So what I'm saying that take 1 and left shift it with 2. Okay, because this is at this particular position. Okay, so I'm going to left shift it with 2. Okay, so now what I'm going to do, 1 is this like this, 0 0 0 1. Okay, left shift to 2. Okay, so 1 is going to move here, then it is going to move here. So here this is what I'm going to get after left shifting. And now do the AND of this one with this one. Okay, so 0 1 0 0 0 1 0 0 0 1 0 0. So what is output I'm getting? I'm getting 0 1 0 0 only, which is nothing but 4, and 4 is greater than equal to 1. So that simply means that this bit is set. Okay, so that's what I'm going to check here. Okay, now let's run it. Okay, let's run it. Let's submit it. So see, our solution is accepted, right? And the time complexity is going to be nothing but O of n. Okay, because this is I'm running for 30 times, and here I'm iterating over all the conditions one by one. Okay, so O of n you can say. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.